Hey everybody, it's Silversherm, and welcome back to the Blender Solar System. Last time we took a look at planet Earth, and now we're moving on to Mars. Mars is the fourth planet from the Sun and the second smallest planet in the solar system. Its distinctive coloring has led it to be known as the Red Planet, and it is this color that led the ancients to name it after the Roman god of war, known to the Greeks as Ares. So Mars has a diameter of just under 7,000 kilometers, which is about 1/2 of Earth's diameter. And it rotates on its axis once in about 24 hours and 37 minutes, so its day is only slightly longer than Earth's. Mars is tilted on its axis by about 25 degrees, and as such, it experiences seasons similar to Earth's, though they're longer because of Mars's longer orbit. And Mars's seasons can be seen through the size of its polar ice caps. They shrink in winter and shrink in summer and grow in winter. Now, the Martian system has two tiny moons, known as Phobos and Deimos. These two moons were discovered in 1877 by American astronomer Asaph Hall. Deimos on August 12th and Phobos on August 18th. After discovering these moons, he named them after the twin sons of the god Ares, with Phobos being the personification of fear, and Deimos the personification of terror. Now, these moons are both tiny and irregularly shaped, though in Blender, I do have them as ellipsoids just because it would be kind of a pain to replicate their exact shape. But here they are anyway. Phobos is the larger and innermost of the two, with an average diameter of about 24 kilometers, and Deimos, the smaller and outermost of the two, has an average diameter of about 12 kilometers. Now, Phobos orbits Mars an average distance of about 9,400 kilometers, and it is actually closer to its planet than any other moon in the solar system, while Deimos is at around 23,500 kilometers. And both of them have almost perfectly circular orbits. Phobos orbits Mars in just about 0.3 Earth days, while Deimos takes about 1.26 days. Because Phobos is so close to Mars, it is actually getting closer to Mars every year. Eventually, it's going to crash into Mars or break up and turn into a ring, while Deimos is slowly moving away from Mars, much like the Moon is slowly moving away from Earth. Now, I have a camera set up so that we will be able to observe the motions of Mars's moons as they would appear from Mars. So I'll select Phobos and Deimos so we can see them, and I might have to make it even slower. Okay, yeah, that's Phobos over there. And we should see Deimos eventually. Now, because Phobos actually orbits Mars faster than Mars rotates, it rises in the west and sets in the east, and moves across the sky in only about 4 hours, twice every day on Mars. Deimos, on the other hand, orbits just slightly slower than Mars rotates. As such, it rises in the east and sets in the west, just like our own moon. But as it slowly falls behind the rotation of Mars, it moves across the sky very slowly. As you can see here, it is way slower than Deimos. It takes about 2.5 Earth days just to cross the sky, and then it doesn't rise again until about 5.5 Earth days. And you can see how fast Phobos is from Mars compared to Deimos. There we go. Now, I'm gonna set this camera to focus on Deimos. So we can get a more realistic look on what exactly the moons look like from Mars. Okay. So we've got Phobos and Deimos in nearly the same spot. Let's zoom out a bit so we can see both of them. A little more. That should do it. And great, I got them showing their dark sides. That's perfect. I'm gonna offset the sun so we can see. So we can actually see them. And there's Phobos and there's Deimos. Their relative sizes as viewed from Mars. So with all that out of the way, let's take a look at Mars's orbit. So, back in the solar system, we can now see Mars's orbit. Mars orbits the Sun in just under 687 days, which is about 1.9 Earth years. Mars has the second most elliptical orbit of any planet, after Mercury, and its orbit is only slightly inclined. It's pretty close to Earth's orbital plane. And Mars orbits the Sun from an average distance of about 228 million kilometers, which is just over 1.5 astronomical units. And you can zoom in to see Mars. I do have Phobos and Deimos in here, who, by the way, are also tidally locked to Mars, always showing the same face, just like our own moon. But with all the stuff I have in this file, it just doesn't even bother to actually make them show up, so moons that tiny being here is kinda pointless, but whatever. So, now that we have the inner planets modeled, I'm going to go ahead and look at them from Earth's perspective. I have the same camera from before. And we can start by taking a look at the sun. Let's zoom in a bit. There we go. Now I'll check out the moon, which looks about the same size as the sun from Earth. And we can see the phases of the moon, which, because of Earth's own orbit, takes a bit longer than the moon's actual orbital period. Phases occur in 29.5 days. And now, if we look over at Mercury and Venus, you'll see that because they are close, they orbit within Earth's orbit, they go through phases just like the moon, except in reverse. And these occur over its synodic period, which basically describes the time it takes for between full illumination as viewed from Earth. So we can see it with Mercury, and we can also see it with Venus, which has the closest approach to Earth than any other planet. Though, on average, Mercury is actually the closest planet to Earth, but because it's the innermost planet, it's actually on average the closest to any other planet. Now, Mars is different. Because it's further out from the Sun than Earth, it doesn't show all the phases, and never appears to be less than a gibbous. I can also use this depth of field to make Mars the focus object, which generally makes it appear better, but it seems fine without it. So now, I'm actually going to go ahead and move the camera let's see if I can get this to make sense. I'll unparent it from the Earth. So there. Then move Mars off its orbit. Parent the camera to it. Put Mars back on its orbit. And yes, the camera's on Mars. And I'll have it point towards Earth. And now, if we look, we can get a glimpse of Earth as viewed from Mars. We zoom out further, we can see the moon alongside it. And now, before we finish up, there's one more phenomenon I'd like to show you. It's quite rare, but every once in a while, a viewer from Mars would be able to see Earth passing over the face of the Sun. The last time this happened was on May 11th, 1984. So how about we check it out? I'll have the camera pointed towards the Sun. Let's zoom out a bit, though. And go back in time to 1984. Now let's see if we can see where Earth is. There we go. And we can see Earth passing over the Sun. And if we go back to rendered mode, you can see that black dot on the face of the Sun. If we go a little further, the Moon follows alongside it. So, that's it for Mars and the inner solar system. Next time in our Blender solar system, we're going to move on to the outer planets. See you then.